This video will aim to explain free radical substitution, and we're going to take on the mechanism, looking at each step individually. The first stage being the initiation, and this kick-starts the reaction. So here we have our chlorine molecule. We hit this with some ultraviolet radiation, then we're able to break the covalent chlorine-chlorine bond, and what you'll probably notice is that these chlorine atoms that we've created each have an unpaired electron, and we'll refer to these as chlorine radicals. And in the chemical equation we'll represent a radical just by putting a dot at the top right hand corner of the atom which has the unpaired electron. And this process is an example of homolytic fission, as the bond has broken evenly. So when the covalent bond broke, one electron went to each of the atoms. In a chemical equation we could just simply represent this as chlorine molecule going to two chlorine radicals, and you'll often see UV written above the arrow. We'll now look at the propagation stages, and for this reaction there'll be two propagation stages, and this will be the radicals that we've just created trying to find electrons from somewhere. So in the first propagation stage, the chlorine radical, which is extremely reactive, is going to try and find an electron from somewhere. So here's our methane molecule. So the chlorine radical is going to try and find an electron from the methane molecule. There's nowhere for the chlorine to go just yet, so what the chlorine radical is able to do is to drag an electron away by taking a hydrogen atom away from the carbon. We can see that the products of this reaction, we have hydrogen chloride and a CH3, but now we've also generated a radical on the carbon, so we have a methyl radical, which we would represent as CH3 with a dot. So sometimes you'll see it on the right hand side. I suppose more accurately the unpaired electron is on the carbon. So how would we write this down? Well, we've simply got a methane molecule reacting with the chlorine radical, and this makes the methyl radical as well as hydrogen chloride. So the story continues in the propagation step. We have our methyl radical, and this in turn is going to be very reactive and be looking for an electron, and bear in mind that we know that we're going to be making chloromethane as one of our products. So this methyl radical requires a chlorine as well as an electron. There are two choices for the methyl radical. Choice number one, the most obvious thing, is for us to bring along a chlorine radical. This will give us chloromethane as a product, but there will be nothing else created, and this is a termination step which we'll look at in a moment. So the other place the methyl radical can find a chlorine and its electron is from a chlorine molecule. So if we take one of the chlorines with its electron, then that gives us chloromethane, and it will also create something which will continue this reaction as a propagation. And I'm sure you've noticed that this species also has an unpaired electron, so we've now created another chlorine radical. Let's go to the equation. So there we had the methyl radical reacting with chlorine, and this gave us chloromethane and our chlorine radical. Let's have a look at those two equations together. So in the first reaction, we used the chlorine radical, which was regenerated in the second reaction. That makes the chlorine radicals a catalyst in this process, whereas the methyl radicals were produced in reaction number 1, but then they were used up in reaction number 2. That makes the methyl radicals an intermediate. And if we remove the catalyst and the intermediate from the overall reaction, we're left with methane. Chlorine makes chloromethane and hydrogen chloride. Finally, we move on to the termination step, and this is where radicals will combine. So here's our reaction vessel, and flying around are the different types of radical that we've got. So what possible combinations of radicals are there in this scenario? Well, number 1, it might be that a chlorine radical bumps into another chlorine radical, like so. Making a chlorine molecule. It may be that a chlorine radical comes into contact with a methyl radical. Like so. And this will make chloromethane. Or it might be that 2 methyl radicals combine. Like so. And that combination will give us ethane. So let's have a look at those 3 possibilities as equations. So the first one, we just had 2 chlorine radicals making chlorine. In the second one, we had a methyl radical and a chlorine radical making chloromethane. And in the third example, we had 2 methyl radicals producing